Hello, this is the luckiest maths teacher in the world talking to you today about operations with terms. So we're just going to review how to add, subtract, multiply and divide terms. So let's look at what they are first. So let's say I have something like this, 4x plus 5. So this is referred to in maths as an expression. And it is an expression with two terms. So the two terms are not 4 and 5. 4x is one term and 5 is another term. Both of them are terms. Now you can tell terms in expressions because they're separated by plus or minus signs. So we need to know a couple of definitions before we get going with the arithmetic. So the first thing we need to know is about a constant term. So a constant term is just a number by itself and it's not attached to, it's not written next to any prenumeral or letter. Prenumeral is just a proper maths term for letter. So in this expression here, we have 5 as the constant term because there is no letter attached to the 5. Okay, the other thing we need to know about is coefficient. So coefficient just means number in front of pronumeral, which as I told you means letter. So here, for this term 4x, we say the coefficient of x is 4. So again, that just means the number in front of x is 4, okay? Now also remember 4x is the same as 4 times x. We just usually don't write the multiplication sign. Now these definitions are important because it turns out that when we add, subtract or multiply terms or whatever, we do the operation on the coefficients. So we're going to first look at addition and subtraction. So addition and subtraction of terms can be a little bit tricky. The reason is we can only add or subtract like terms. So let's first look at what like terms actually are. So it says on your screen, like terms are terms with the exact same sequence of pronumerals. Remember again, pronumeral just means letter. So let's look at some example of like terms. So the terms x and 4x, they are like terms. Even though the coefficients are different, actually the coefficient of x is just 1 because x and 1x are the same thing. Even though their coefficients are different, they both have 1x and no other letters. That's why they're like terms. The terms xy and yx are like terms. Even though they're written in a different order, they both have 1x and 1y, no other terms, therefore they're like terms. So by that logic, ABC and let's say 12CBA, they're like terms. They both have 1A, 1B, 1C. Again, it doesn't matter if they have a different coefficient. So let's go ahead and look at some unlike terms, terms which are not like terms. So let's say 7 and 7y. They are not like terms. They both have the same coefficient, but they don't have the same sequence of pronumerals. One of the terms has a y, one of them does not have a y. 2x and x squared are not like terms. Now you're probably thinking, well, hey, don't they both have 1x? Surely they must be like terms. But x squared is actually the same as x times x. So there are two x's in this term, only one x in this term. That's why they are not like terms. Another example of not like terms, ABC and let's say 10BC. Okay? So even though both terms have 1b and 1c, only this term has an a, therefore they're not like terms. So what I'm saying is that I could add these two terms together, these two together, and these two together, or I could subtract them, but I can't add these together, I can't add these together, and I can't add these together. So once you've got like and unlike terms down pat, addition and subtraction is really easy. So I'm going to rub this out and we're going to do some examples. So please pause the video if you'd like to copy it down. So I'm going to go ahead and do each of these 4 examples. In each case, I'm going to collect the like terms and simplify. I'm going to write this as simply as I possibly can. So the first one, 2x plus 3x, that's easy. 2 terms, and they are both like terms because they both have 1x. So if you have 2x's and you add 3x's, you now have 5x's. Simple as that. Second one's only a little bit complicated because there's no number in front of y. But as I was saying before, y is the same as 1y. So I can write the 1 there if I like. You don't have to, but it might make it easier. So then this is 7y minus 1y. So if you have 7y's and you take away 1y, you now have 6y. The third one's a little complicated because now there are 3 terms. 1, 2, 3. The first and the last term are like terms because they both have an x, but the middle term has no like terms, has no friends, because no other term has a y in it. So what we do is we take the ones that are like terms. So I'm going to take the 8x and the 4x and add them together. So I'm just adding the coefficients each time. 8 plus 4 equals 12, and I add the x in there. So that's 12x. Then I leave the middle term alone. I write it exactly as it was before, minus 3y, because I haven't done anything to it. All right, the last one has 4 terms. So 3 of them are like terms with each other, but 1 of them is not. So let's go ahead and do this. So I go 10ab plus 5ab. That gives me 15ab. I just add the coefficients. Then I have to subtract 3ab. So 15ab minus 3ab, 12ab. So I've just gone 10 plus 5 minus 3 is 12, and then I write in the ab. And again, the next term, the second term, has no like terms, no friends, so I leave it exactly as it is and I don't change it. All right, now we're going to go on to multiplication and division. Please copy this down if you need. So you'll be relieved to know multiplication division of terms is actually quite a bit easier because you don't need to worry about like terms. You can multiply and divide terms even if they're not like terms. So let's look at something like this, 2 times 3y. Remember, timesing something by 2 is the same as adding it to itself. So this is just 3y plus 3y, which equals 6y, because I can add these two terms. They're like terms. That's why I'm able to multiply terms even if they're not like terms. Now, similar to addition and subtraction, in this case we just multiply or divide the coefficients first, and then we'll worry about the letters. So let's go through a few examples. All right, let's go through these examples. So the first one, 4 times 5y. So that's easy. We just multiply the coefficients, 4 and 5. And then we're multiplying by y as well. So it's 20y, because 4 times 5 is 20. Second one, so we'll multiply the numbers first, the coefficients. So 7 times 3 is 21, times 2 is 42, and then I'm multiplying by b and c. So the next one, 18ab over 3. Remember, this line here means divide. So 18ab divide 3. So 18 divided 3 is 6, and the AB were on top, so it's 6 times AB. Now the last one's a bit more confusing. So we have 6y divided by 9yz. So the way that I go about dividing 6 by 9 is to simplify it, because I can't divide 6 by 9 and get a whole number. So what I do is I simplify the fraction. And if you're stuck on that, you can just put 6 over 9 in your calculator and it will simplify it for you. 6 over 9, or 6 divided by 9, equals 2 over 3. So that's the first part done. Essentially, I've divided 6 by 3 to get 2 and 9 by 3 to get 3. Now, if you have a y on top and bottom of the fraction, I can cancel these out because y divided by y just equals 1. They cancel each other out. Now I'm left with a z, but unlike in the last example, the z's not on top of the fraction, it's on the bottom. So in your answer, you must write it on the bottom. So this equals, sorry, I'll write that properly, 2 divided by 3z, or 2/3 over z. So, please ask if you have any questions. I hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.